So for lesson 9 homework, we're going to continue our work with secant and tangent segments. So determine the value of x for the diagram below. So we need to do our outside times whole equals outside times whole rule. So if we look at the top here, the whole thing is very clearly x. That's nice. But now the outside part, well, if the inside is 27, CB, the outside part is going to have to be x minus 27. And that's going to equal, well, here, the outside part, the whole thing is clearly 20. And if the inside part is 12, that leaves us the outside to be 8. Okay, so we have our outside times whole equals outside times whole. Yes, I may have written whole times outside. It's the same exact thing. So we'll distribute here. We get x squared minus 27x equals 160. Now, as I look at this, this looks like it's going to be a factoring problem because we've got an x squared and an x in the same problem. So in that case, we'll set it equal to 0. So it might take you a little while to figure out what multiplies to negative 160 and adds to negative 27, but your answers are a negative 32 and a positive 5. So negative 32 times 5 is negative 160. Negative 32 plus 5 is negative 27. So we'll take each of those and set them equal to 0. We'll subtract 5 on both sides. That gives us x equals negative 5. Now we're talking about lengths here, so we know that has to be out. So then we'll add 32, and that gives us 32, and that makes 32, not 34, and that makes a lot more sense. So the value of x here is going to be 32. As we look in part B here, so again, outside times whole, so x times x, so for the tangent, the outside and the whole are the same thing, is equal to, the outside is 4, the whole thing is 13. So this is exactly like the one we had in class. All right, we'll square root. 52 is not perfect. It splits into square root 4, square root 13. And that's going to give us a value for x of 2 radical 13. So here, same thing. We are going to find the value of hg. So it's going to be outside times whole equals outside times whole. So for the tangent, x plus 8 times x plus 8 equals, outside of the top is 12. Whole thing is 12 plus 15, which is 27. So when we multiply this out, we get x squared plus 8x plus 8x plus 64 equals 12 times 27 is going to be 324. So I'll add my 8x's together. At the same time, this looks like another factoring problem, so I'll set it equal to 0. So we get x squared plus 16x, and then 64 minus 324 gives us a negative 260. So again, factoring, got to figure out what multiplies to negative 260 and adds to a positive 16. So again, might take you a little while, but you get x plus 26, and you get x minus 10. So we'll set each of those equal to 0. So minus 26, that gives us x equals negative 26. All right, again, we're talking about lengths, so that can't be it. And then we'll add 10, and that gives us that x is 10, and that's more of a reasonable length for x. But it wants to know what's the value of hg, so we'll take that 10, add it to the 8, and that gives us hg is 18. Number 2, in circle O, tangent is drawn from arc A to the circle at point B. Drawn from A, not arc A. Secant ADC is also drawn, and it has a length of 12 inches. So they'll tell us the whole thing here is 12. If AD to DC is in a ratio of 1 to 3, determine the length of AB. Well, first off, let's deal with the ratio. So if AD to DC is 1 to 3. That means we are 1x to 3x. So if we take those and we add them up and set them equal to 12, that gives us 4x equals 12. Divide both sides by 4. That gives us that x is 3. So that gives us 3. And 3 times 3 is 9. So that makes sense because 3 plus 9 is 12. So we'll call AB y here, all right, because we already used x for our ratio. So outside times whole equals outside times whole. So y times y. I'll make that a little bit cleaner here. So y times y equals, outside is 3, whole thing is 12. So y times y is y squared. 3 times 12 is 36. Square root both sides. And we get that AB is positive 6. All right. So we deal with our ratio. Then we do our formula. In circle O, chord AOB is drawn. And you can see AOB is a diameter because it goes through the center. Point C is located on the exterior of the circle with tangent CB and secant CDA drawn. It is known that CD is 2 and DA is 6. What's the length of BC? So this looks like an outside times whole equals outside times whole question. So I'll add my 2 and 6 to get to 8. So x times x for my tangent equals 2 times 8. We get x squared equals 16, square root. And we get that x is 4. So BC is going to be 4. What is the length of the radius of circle O in simplest radical form? Well, AOB is a diameter, which means OB is a radius. So when it intersects that tangent, it makes a right angle. So now we can find the whole length of the diameter, we'll call it y, by doing Pythagorean theorem. So that's going to be, now 8's our hypotenuse here. So it's going to be 4 squared for what we found for the bottom. So 4 squared plus y squared equals 8 squared. So we get 16 plus y squared equals 64. We'll subtract the 16 on both sides. We get y, I'm going to bring it over here, we get y squared equals 48. Square root. 48 is not perfect, but it does split into square root 16, square root 3. So that gives us that y is going to be equal to 4 square root 3. All right, so we used our radius and tangent, make a right angle, to find our diameter, which is 4 square root 3. So that means the radius is going to be that cut in half, which is 2 square root 3. All right, so remember y represents our whole diameter, so then the length of any of the radii in this are going to be divided by 2, which is 2 square root 3. Determine the measure of angle C. Consider your right triangle trigonometry instead of circle theorems. So again, we're dealing with a right triangle here. So if we are going to find that, we'll call it theta. You could use either the 4 square root 3 that you found. So you'd have your opposite, you'd have your adjacent, and your hypotenuse. But rather than use the radicals, I'm going to use adjacent and hypotenuse, which would be cosine. So cosine theta equals adjacent, which we found was 4, over hypotenuse, which is 8. We will arc cosine or cosine -1 both sides. And when we do that, second cosine 4 divided by 8 gives us a 60-degree angle. So angle C is 60 degrees. So then find the measure of arc AD. Show how you arrived. Well, if we know we've got a right angle, and we know this angle we just found is 60, following our triangle rules, that would give us angle A has to be 30 degrees. So then going out from 30 gives you arc DB as 60. So angle 30 was inscribed to that arc. We've got a semicircle here of 180 degrees. So we'll finish this off with 180 minus 60. And that's going to give us a 120 degree arc for AD. So a mix of a bunch of different things there to do our homework. But if you can kind of just piecemeal it together, you'll find that you can get everything no problem.